Normal distribution. Remember at the top left there, we see the empirical rule, 68, 95, 99.7. If you have that in your brain, that is how we determine these numbers. Data that's normally distributed, 68% of the data falls within one standard deviation of the mean. 95% of the data falls within 2 standard deviations of the mean, and 99.7% of the data falls within 3 standard deviations of the mean. All right, let's make something up. Let's say that I have a set of data that's normally distributed, and the mean is 80. So that'll go right here in the middle. And the standard deviation, let's say, is 5. Then I would add 5 every time I go to the right. And I would subtract 5 every time I go to the left. All right. Now, the things you might be asked are what percent of the data falls between 75 and 85? Well, between 75 and 85 would be, by the empirical rule, 68% of the data, or you could just add these two numbers. Maybe the data might ask what percent of the data is greater than 85? That would be this way, and you could add up 13 and a half, 2.35, and 0.15 to get 16%. If you come across questions that ask you things like, for this one, tell me the difference percent between 72 and 87. Oh no, those numbers aren't on the bottom of my curve. Whatever shall I do? You can go to normal CDF, CDF, never PDF. You'll find this on your calculator by hitting second vars. If you're in my class, you probably like to chant lower upper mean standard deviation. If you're in Miss Dishman's class, or any of you really, notice LUMS. Sometimes we remember that because it spells lums, so that's another way to remember. Second vars, normal CDF, never PDF, lower upper mean standard deviation. So if I ask you to find data between 76 and 86, you could type in normal CDF, 76, 86, use the mean of 80 that we were talking about, and the standard deviation of 5. Yay.